I think most of us are back. Let's start. So we were good with block size. Next comes the installation part. So there are three basically ways to install Hadoop. The one which I recommended you for all of you to try was standalone. Go for it. Create like install VirtualBox, install a VM on it, or a Hadoop variant. That should be just fine, and you can write all the commands that I'm going to share with you, and you can have that exposure. Nothing else. Pseudo distributed system is basically, think of it as creating your main machine as master and a VM as a slave. That becomes a pseudo distributed system. A fully distributed system is basically over cloud, or where you are creating, like if you have a 32 gigs of RAM or even more RAM, then basically 32 gigs or more of RAM is available, and then you can create 4 to 5 VMs. Then you can actually have exposure to fully distributed system. Or if you have some free cloud credits of any like AWS or Azure, then you can try this fully distributed system. Multiple top-notch distribution that we discussed in yesterday's class were Cloudera, Hortonworks, MapR. Feel free to go, or you can use through IBM, Microsoft, or EMC. EMC is the one which got acquired by Dell. So yeah, now it's Dell Pivotal HD. That's that. Feel free to explore. So the Hadoop daemons that we are talking about, basically these are the components. Daemons are nothing but the processes that basically works in backend of an Hadoop system. Name node, data node, secondary name node, job tracker, task tracker. In V2 it's called resource manager, and V2 is called node manager. So I hope everyone is now good with the terminologies. If someone says job tracker, you know that what they're talking about. If someone says task tracker, you know what they're talking about. Name node, data node. Any questions? I'm going to pause on this slide for a minute. Let it just stay there for a while. Take a look at it. Let me know if you have any questions. Yes. Okay, tell me.
If 5 blocks is assigned to a slave node, they process all these 5 nodes parallelly, or they do it one by one or something, some other way?
I'm sorry, come again. What do you mean by 5 nodes are assigned to a?
Sorry, 5 blocks. Sorry.
5 blocks are assigned.
If 5 blocks are assigned to S1, slave node 1, do they process it parallelly, or one by one all these 5 chunks of data?
Okay, so good question. Now the way it works is it depends on the configuration of your slave. So let's say if your slave has a quad core processor or a multi-threaded processor. Let's say let's take assumption of that your slave has a quad core processor, 4 cores are there, and let's say 16 gigs of RAM is there. Now you have assigned 4 blocks to that particular slave. So now those 4 blocks can be executed. Let's say 3 gigs of RAM can be assigned to each task. And you can say those 4 blocks are already existing on the space, and each one core of processor will be assigned to each block to process each block. So those 4 blocks can be processed in parallel on the same node as well. So it basically depends on the configuration of the slave node that you have. If it has multi-core, multi-threaded processor, multiple processes or tasks can be run in parallel, then yeah, certainly they would. If not, then they won't. So it depends on the configuration. That's why these two things are there, right? Resource manager and node manager, they negotiate resources with each other. Whatsoever is available, they utilize the maximum of that. Good question, KK. And any other question anyone has?
One question I have, Shubham. Like on the master node, basically on the name node, we have different processes, or maybe more processes from the data node.
Different processes, yes. So you can say resource manager will have different things to do as compared to what our node manager would do, because resource manager has to, like you can say yarn in this case. Let's talk about yarn to be precise. So Jan, yet another resource negotiator, would do the resource negotiation as well as assignment of the task, as well as retrieving of the result, as well as managing the metadata. Like where does what exist on which node, and what is the result of that? All of those things. So
Okay.
yeah, I mean, these are different, you can say, tasks which will be acting on each of these. It's not like name node has same chores to do as compared to data node. Remember I said that a name node would have a more RAM and lesser storage as compared to a data node, which will have less RAM and more storage.
Yes.
I mean, this comparison that I'm telling you of more RAM, less storage or thing between name node, data node, that is an ideal scenario. But ideal scenario does not exist in the world. So most of the time we end up having even name node of the same configuration as the data node. Okay, I am assuming, can you give me that you have no questions, just type in no in the chat. I will move ahead if I get, when I get 3 no. Or if you have any questions, just go ahead and ask me that.
One different question from this, Shubham.
Go ahead.
Does this blockchain technology works on Hadoop?
No. Blockchain technology is decentralized. That's different. Right now we are talking about distributed system, not decentralized system. Decentralized system are different than the distributed systems. Any other questions? I need no in the chat, 3 no's, and I will move ahead. So if you have understood all the concepts, you don't have any questions, just type in no in the chat and we can move to the next slide. And if you have any question, feel free to ask them. No worries. Rupesh says no, Shrikant says no, Sayali says no. Awesome. Okay, Hadoop Daemon secondary name node. Again, we have gone through this. Node manager as a master node, act as a master node and pass on the commands for processing of data to / from the slave node. Resource manager act as a slave node and obeys to the name node processing. Simple. And okay. Now here comes the workflow which we have discussed. Now we can discuss in terms of name node job tracker, data node task tracker thing. And actually there's nothing much. This workflow is something that we have already discussed. Do you have any question with respect to this workflow? Take a look at it. I mean, who does what? Any questions at all? I guess not. Hadoop distributed file system, local file system, and Hadoop distributor, guest to host to host, HDFS command, approximately Unix command. Let's do some HDFS command. Knowledge. Let's do the knowledge check. What are the 3 varieties of data that can be processed in Hadoop? Can anyone answer me this question?
Variety means semi-structured, structured?
Yes. And the third one is?
Unstructured.
Perfect. What is the block size in Hadoop version 1 and 2?
64.
Into
64 and 120.
Perfect. What are the 3 pseudo distributed system packages that are open source? Okay, that's basically they are talking about Hortonworks, Cloudera, Mapr. Mention all the daemons. Who can mention all the daemons? Daemons are the components that we discuss in Hadoop architecture. Yes, Sayali.
Master, slave, node manager, resource manager.
No, I don't want master and slave. I know the another name.
Job task.
Name node, data node.
Name node, data
Name
node.
node.
Yeah. Go ahead, Sally. Sally, keep going. Name node, data node. What else?
Name node, data node. JT is there. Job tracker is there. Task tracker. These are
Okay.
demons.
Yes. Then other name of these are resource manager, node manager.
Node
correct?
manager. Yes.
Correct. Then you forgot secondary name node.
Yes. SNN, secondary name node.
Perfect. Which background service is the master and slave for MapReduce approach? We haven't discussed that yet. What are the different negative scenarios that can happen in a HDFS workflow? Negative scenarios, can anyone tell me?
Anything happens to the master or anything like any network
Slave.
issues happens in a slave node. So
Correct. Those are some negative scenarios. But I was talking about in terms of, let's discuss block size. But if I make block size of 4 MB, is it a negative scenario or a positive scenario? Sorry?
Negative. It's too small. Negative.
Negative. Good. Perfect. So I think we all are on the same page, and this is the end of this slide. Perfect. Anyone has any question with respect to these topics?
Shubham, can you go back to that HDFS page
Sure.
where there was some diagram and ABCD something it was written.
Okay.
Here ABCD, the ABACD, these are the blocks.
Yes.
So as per the replication factor, the all blocks should be present on all the servers.
No. By default, if you remember, replication factor is 3. So if you will see, right,
Okay.
A, there are 3 copies of it.
Okay, got it.
Good observation. Location. Sorry?
If
Yeah,
you
tell
don't
me.
mind, can you please explain this workflow? Actually, I was got disconnected.
No worries. Yeah, sure. So what's happening here is we have a name node, right? I'm assuming that you know the different components of the Hadoop ecosystem.
Yes.
So Hadoop architecture. So we have a name node, which will have a job tracker, in other words, resource manager, which will interact with data node, which are the slave nodes, which will have a task tracker, in other words, which is again called node manager. So this resource manager or job tracker or task tracker will interact with each other in order to assign tasks from master to slave. Like the program will be sent from this job tracker to the task tracker. Then this task tracker further execute that program and returns the result to the job tracker. Now what happens is, let's say we have these 4 blocks, right? A, B, C, D. Now, if we will, since we have 4, you can say slave nodes, what we can do is we can send this, basically when we assign this job tracker, we can say that, hey, I need, I would like to use all the available resources and need the result in the minimum amount of time, something like that you have said to the job tracker. So what job tracker would then, what it would look for is, or resource manager would look for, is that how many nodes are available to him, to make how many worker nodes are there or slave nodes are there. So they will see that, okay, 4 nodes are there, 4 nodes are available. Okay, then the resource manager will see, okay, how many blocks are there to be processed. Then you will see like, okay, there 4 blocks are there. So they will say that, okay, I can process each block on each node in parallel to get the result in the minimum amount of time, and that will be the fastest. So what it will do is it will send a task. You can say it will assign a task to each of these task tracker 1, 2, 3, 4, and with respect to a specific block, that you process A, you process B, you process C, you process D. So now this TT1, TT2, TT3, TT4 will start processing the same program, let's say count of words on each of these blocks, A, B, C, D respectively, and then we'll give back the result to the job tracker. Their job tracker will again consolidate the result. So let's say this gave the word count as 10, 20, 30, 40. So what it will do is it will do 40 plus 30, 70 plus 20, 90 plus 10, 100. So it will give you the final result of 100. That's how your program will get executed in a Hadoop distributed file system in a Hadoop architecture.
So
in
here
a lesser amount of time.
So here A block is being getting replicated at 3 times at 3 different slaves, right?
Correct, because by default replication factor is 3 and we are assuming we haven't changed. Hence, every block is replicated thrice.
Yeah. Thank you, Shubham.
Sure, no worries. Okay, this is important. I mean, this is main gist of, you can say, Hadoop. Once this is done, then all that is remaining is MapReduce. Then MapReduce is done, then the Hadoop MapReduce is done. Now, then there are just certain components which we can discuss at lower level. And your Hadoop is done, then main thing will start, that is Spark, which is used very extensively nowadays.
Shubham, I have one question.
Sure, go ahead.
Any company or organization which is in current days solely completely relied on the Hadoop cluster or Hadoop infrastructure?
There are many. There are many. So I'd say, remember if you said initially I said 90% have moved to Spark and 10% are still on Hadoop. Then let me assume that in globally there are, let's say, 1 lakh companies. Then 1 lakh of 10% of 1 lakh is, let's say, 10,000. So there are 10,000 organizations we are talking about here, which are still working on Hadoop. And the only reason they are working on Hadoop is because they don't want to upgrade, they don't want to migrate their on-premise architecture to cloud, or they don't basically want the further optimization. Right now there is no need, that's why they are not upgrading. So if you ask, you can say TCS will have certainly a project related to Hadoop in India. TCS must be still 100% for sure, must be some working for some XYZ clients on Hadoop. They will be Hadoop and in Hadoop developed TCS. TCS, Infosys, Wipro for that. I mean, all the service-based company in India, like TICA, TICCAW, that is TCS, Infosys, Capgemini, Cognizant, Accenture, Wipro. And for that matter, Tech Mahindra and HCL, you can add them also. These are all service-based companies in India, which will certainly have at least, I guess, 1 or more clients which will be working on Hadoop still.
Any product-based company?
Product-based company on Hadoop? No,
Yeah,
I don't think so. It's hard to think of. I'll tell you why. So generally, when the IT folks talk about product-based company, we're talking about technical product-based company. That is nothing but Meta, Amazon, Apple, Netflix, Google, Microsoft, all of these, correct? Now, Google, Amazon, and Microsoft, these three will never go and work on Hadoop because they all have their own cloud. So it's their responsibility. If they do not themselves advance their internal architecture to, you can say, Spark, then how can they sell it? So Amazon, Google, and Microsoft are out of the picture. Now what's remaining? Apple, Netflix, and Google. Netflix need, you can say, Netflix has the best architecture, and it is basically on cloud. So they are the, I don't even want to say it. I will show you. Netflix architecture. This looks fairly fine. Here comes the Kafka EMR. They're using EMR. Although I think this diagram is also kind of old. But again, EMR is not Hadoop, it's a managed service, you can say. And I'll not rather say that it's Hadoop. Yeah, let's go with EMR. I think all have it now. So architecture wise, this is using EMR. Let's go with Hotstar maybe. Hotstar architecture. No, this is not that. Can you tell me one data related company which has huge amount of data? I guess Visa. There you go. Visa is not upgraded. Visa is still using Hadoop admin. I mean, they're still using Hadoop, so they need Hadoop administrator. Sorry, this job has expired. Oh, so even they are not hiring. I'm not sure what was the job post date. Are you able to see any date? No, right? No, so even Visa is not using. Okay, data engineer. Yeah, they have moved on to yes. So yeah, even Visa has moved to Spark. The reason you are able to see Hadoop, remember I told you Spark's underlying file system is Hadoop only, hence they say Hadoop, but they are using Spark for data processing, not Hadoop. I mean, not MapReduce. Traditional Hadoop ecosystem, they are not using that. They are using Spark. So even Visa has moved on to Spark and not using traditional Hadoop. Which I mean, what other company do we have? MasterCard maybe. The MasterCard is Hadoop or Spark. MasterCard reduces MTTR and subscribers.
I think financial companies like Citibank or are they using?
Even they would have moved. If MasterCard has and Visa has moved, I'm pretty sure. Citibank data science interview, they are asking question related to, I think I saw Spark. Where is it? Yeah, Spark. They are also on Spark. Everyone has moved their data processing engine to Spark. 10% companies which we might not be able to find as of now will be going towards traditional Hadoop, like writing my MapReduce job, submitting it, getting the results. Nah, old-fashioned way. But yeah, only 10%. No big companies I can think of now. If Visa, MasterCard, and Citibank, these kind of companies are not using, then if they have upgraded, then yeah, everyone else would have upgraded. Any big company you might think of, they would have upgraded. Cool. So next we will move on to the MapReduce. Oh, I have only 15 minutes. Okay, then I won't start this. Give me a sec. Let me load this also. This is done. This is MapReduce. This is Sparkman. We have mutation and correct. So this one is not this one we want. MapReduce. Correct. I will start that next week, not tomorrow. What else? So what I'll do is I'll go through some questions actually now. To test knowledge, and if something has remained, like if we have forgotten and we have not discussed, we can do that. Explain big data and list of its characteristic. We are all good with this question. Volume, velocity, veracity, variety. Anyone? We had a detailed discussion yesterday. Anyone has any question with respect to this? Okay, I assume no questions. Explain Hadoop, list the core components of Hadoop. I think we all can. Explain the storage unit in Hadoop. I think this one we all can. Mention different features of HDFS. Yes, this is something we should discuss. So we understand how we are building a fault tolerance system, a high availability system, a high reliability system is something. Replication we know, scalability also we know, reliability is something we can discuss. As usual, it saves 0 by so even I guess reliability also you all understand. Any questions on this? any of these 5 points: fault tolerance, high availability, high reliability, application scalability. Sayali, any questions?
No, Shubham.
Perfect. What are the limitations of Hadoop 1.0? This we have discussed, right? Hadoop 1.0. HDFS is programmed to work with the MapReduce paradigm. HDFS is cost effective. Okay. Whereas NAS, does anyone know what is NAS? Just to be on the same page, it is this. The full form is this: network attached storage. It's a traditional system actually. So initially we were using NAS with Hadoop because we didn't want to go into the hassle of creating the a storage which is in sync with each other. Because if you remember, right, we are onboarding, whenever we are onboarding a 1 GB file, it is getting split into, let's say, if you're talking about 128 MB block size default, then it's getting split into 8 blocks. So we need to split and store it in such a way so that we can leverage HDFS. So initially, if we will be using NAS, network attached storage, it will happen by default, but not on the basis of block size, on the basis of a different paradigm. But then again, in network attached storage also, you can define the blocks and then get to the same thing. So people started with that. But then that was not actually, you can say, sufficient for a MapReduce job, which you are able to see here. And hence we moved on to this Hadoop distributed file system instead of NAS. Plus it is expensive and this is commodity hardware cost effective. So that's why we have moved from NAS to HDFS. Initially, the master slave architecture, the slaves were on NAS instead of a HDFS fashion. Compare the main differences between HDFS and NAS. I think this was what we were discussing. List Hadoop configuration files. Yes. So the files, description of those files are, this is the Hadoop environment variable where you're going to basically set up all your default file that will be running as soon as your environment, Hadoop environment goes live or makes you make it up and running. And if you remember, right, the configuration thing that I was talking about, and I was referring to YAML, but I did not say that it's YAML because I forgot that it's XML. The configuration in Hadoop environment is stored in XML file and not in YAML, but it is very similar to YAML. Like XML is extensible markup language, very similar to YAML, you can say. But yeah, configuration is stored in XML files. So configuration settings for Hadoop core, such as IO settings that are common to HDFS and MapReduce. Core site XML, configuration setting for HDFS daemon, that is block size and everything, the name node, the secondary name node, and the data node. HDFS site.xml. Then MapReduce job, next job tracker, task tracker related configuration in MapRed-site.xml. Then master will be a list of machine, one per line, that each run a secondary name node. Slave file will have a list of machine, one per line, that each run a data node and a task tracker. Basically, these are the some key configuration file in a Hadoop ecosystem that you should be aware of. Basically, in this file, you will get to know what is the version of Hadoop that you are running. Move on to the next one. Hadoop MapReduce. We haven't discussed this yet. Shuffling, Spark. Okay. 3 modes that Hadoop can run. Discuss this. Hive, Pig, Yarn. We have discussed. Resource manager. It runs. What are list the Yarn components? Yarn components has a resource manager, node manager, application master, and a container. So we have discussed resource manager, we have discussed node manager, we have not discussed application master and a container. Correct? Container is nothing but a combination of resources including RAM, CPU, network, HDD, etc. on a single node. So think of it as a one container will have all of these things in order to complete a task. So you can see that a task will be assigned to a container within a name node. So I think KK has this question: if you assign 4 blocks, if 4 blocks exist on a same system, then remember I was saying if it has 4 cores and 16 gigs of RAM, 3 gigs of RAM, and 1 core will be assigned. So you can say that 3 gigs of RAM, 1 core CPU, and some network bandwidth along with that 1 block of HDD space on that node will be assigned to one task in a container to accomplish, you can say one task within that node. Then there are several containers which can run within a name, within a data node at the same time in parallel efficiently. not a problem. Now, what is an application master? Application master is the one which controls the job life cycle and resource demand of single application. It works with node manager and monitors execution of tasks. So this basically, first of all, what we need to know is that within node manager, there is application master, which is further negotiating. If you remember, right, we were discussing task tracker. The task tracker here is in resource manager, the job tracker, they are negotiating with each other. So another name for that is what we call as application master. Task tracker, job tracker were the old name. New name are application master and resource manager, you can see. These are all very synonyms. If you remember even one or two, that should be fine. You need not to remember all of these. Any questions on yarn components?
Shubham, yarn is present on the master side, right?
The resource manager, yes.
Okay, and container is a part of yarn, and
No, container is part of data node. So the reason these are all, okay, I'll tell you. The reason they are called yarn components is because we are talking about what all are interacting with yarn. Yarn is interacting with application master, yarn is interacting with node manager, yarn is interacting with container. How it is interacting with container? Because at the end of the day, when container completes the task and returns the result, it returns the result to resource manager, correct? So container is interacting with resource manager. Application master is negotiating resource with resource manager. Node manager is sending him the heartbeat signal, sending him where is the data residing, what are the different tasks running, all the status is all of that. So even that is communicating with resource manager, and resource manager is there itself. So these are the different components of yarn. Yet full form of yarn is yet another resource negotiator. Current version is 2, I guess, that we are working on. Yeah, yarn 2, I guess. Yarn was launched in Hadoop 2.x. Yarn provides many data processing like graph processing, batch processing, interactive processing, and stream processing. The execute process data saved in the HDFS.
Okay.
Okay.
Yes.
Then Zookeeper we haven't discussed. Znode not discussed. HDFS command. Actually, this is not important that much. HDFS commands I will share. Scoop haven't discussed. Hadoop integration for experienced. Oh. This CP, then they are going into command. Then they are going into wise. Why are blocks in HDFS size? In HDFS is huge, like 128 MB or even more than that. How you should decide. What is the default replication vector we have discussed? How can you skip the bad records in Hadoop? So that's basically like maintaining a separate file, you can say. You can just skip the bad records and keep a log of all those such records which have skipped while processing. There are the two types of metadata that name node server stores. There are added log FSMS. These are all the file system. They're going into details. Which command is used to find the status of the blocks and file system health? Command based, command, DFS admin tool. These are all, if you will see, right, these are all administrator related work. Nothing is of a you're not able to find a question which is related to a Hadoop developer's job. Yes.
Can we search the questions related to data scientist? Related to Hadoop?
It will be same.
Okay.
I will even search that. Hadoop data scientist. Interview questions. What are different vendors discussed? Hadoop configuration file discussed. 3 modes discussed. Difference between regular file system, Hadoop file system discussed. Fault tolerance discussed. HDFS, types of metadata. I've assumed that command thing that we were discussing earlier. HDFS federation and high availability. High availability we have discussed. This is something which was there. I mean, which is traditional. by default if you do not go into high availability mode. So if you will see, right, HDFS Federation has no limit on the number of name nodes, and the name nodes are not related to each other. All the name nodes are a share a pool of metadata. With each name node will have its dedicated pool. Provides fault tolerance. One name node goes down, it will not affect the data of the other name node. All of these things we have discussed in high availability one. Plus there are other things that it requires to separate machine, because the active name node will be configured while the secondary name node will be configured on the other system. So in this federation system, we are not taking SNN into account, whereas here we have SNN as well. So hence, if you remember this would work. But just to be on the same page, if someone asks you about HDFS Federation, just think of it as it does not have SNN, and name node have a shared pool of metadata. In this case, it won't be there. It will have independent pool of metadata. Like secondary name node and the primary name node will have independent metadata, and not any, there won't be any shared component across. Otherwise, they are same. What do you else? Okay, what do you else? If you have an input of file 350 MB, how many splits? That's a MapReduce question. Rack awareness discussed. How can you restart name node? Command Hadoop Daemon-s stop start. Which command will help you find status of blocks, file system health? File-based question. I mean, basically, if you will see, right, there is no different question for data scientist Hadoop question. It's same. It's all admin related stuff, and they will ask you to check your knowledge of Hadoop. That if you are aware of Hadoop or not, they won't. It doesn't actually matter if you are really working on Hadoop, as long as you know the concepts and you know how it works.